All right. So you guys,
Bluetooth?
Are we excited?
what's up?
Is it Bluetooth?
Possibly. I haven't played with Bluetooth at all, really.
I just meant how you get it hooked up on your board.
There's certain ones on here that I definitely want to go over, but does anybody have a specific question from that first assignment we did?
30 questions.
Yep. Hopefully there aren't 30 questions.
One that you did.
And
Number 6.
6? Oh yeah, so we went over that a little bit. 6 was this one here.
Yeah.
Actually, correct me if I'm wrong. I think we did that one all the way out.
We did.
Yeah, we did.
But let's see. So remember, the trick here is 69 is not an easy number to work with. So I just think that's about 70. And when I don't want to go 70 into 528, I'll go 7 into 52, roughly, just to cut them off. Because I'm just trying to get a good first estimate and not guess a lot of different numbers. So 7 goes into 52 7 times, right? So 7 might be a good first guess. And if it comes out to be wrong, now how do I tell if I'm wrong? If I do the subtraction, what number down here might show up to tell me I'm wrong?
If it's more than 69.
No, like a negative would be bad. If that's too much, then I could stop right there and say it must be the next number down.
Exactly.
Or if I came out with 71, why would that be bad?
Because it's over the 69.
Because it's over the 69. It means there's one more 69 in there. You always have to have a number between 0 and 69 for that to make any, or 68 really, for that to make any sense. So if I do 7 times 69, I don't know if you guys remember, 70 times 7 is 490. So 70 sevens is 490. 69 sevens must be 1 7 less.
That's
483.
483.
Or you can always do 69 times 7, just do that out. No problem there. 483. Subtract. What do you get when you subtract that? 45. Bring down to 9. And then you do the trick again. 7 goes into 45. 6 times. 6 times 7 is 42. So it goes in about 6 times. 6 times 69. Again, you can just do it straight up if you want to.
414.
Yeah, 414. Freaky enough, when you do that, you get 45 again when you subtract. Bring the 6 down, and we already know the answer there. Say the same dude.
6 again.
Subtract that. 42. And then you could write it like this. Or you could write it like
42 over 69.
yeah, 76 and 42 69ths. That's the fractional part over that it was from going in evenly. Either way. I don't want to see the decimals yet. Because that would actually probably never stop. It would probably go forever. And you don't know where to stop yet. So just don't even start. Just put it either as a big old R or even as a fraction if you want to. Is that cool?
The line itself stops it, doesn't it? In that 42 over 6, the line there stops the equation.
Yeah, but what I'm saying is if you tried to make this in a decimal, it would never stop.
Oh, yeah.
It would probably go on forever.
Infinity,
Yeah, infinitely long. I don't have that much time. Okay.
Universal.
Is that cool? Any other questions that we didn't go over? Or that we need to go over again?
There was the one, it was the one bracketed. I don't have it with me.
14?
28,
Oh, the ones without squares and
Yeah,
stuff?
the squares with brackets within the brackets.
Oh, yeah.
That one.
All right.
What's that?
one more
What
time.
number is that?
14, I think.
Yeah.
Yeah. I could almost write it down from memory. Let's see if I can.
Yeah, there you go.
Oh, yeah. So remember, when I look at that, I don't see just a jumble of crap. The people that do really well in math are the people that can kind of break things apart a little bit, but here it's almost bad to break it apart. I kind of put all this together. I see twice something, because one thing I didn't make a big point of the other day is When a number is sitting right next to something else,
Times.
in algebra, that means multiply. Right? There's no operation in the middle here. That's an implied multiplication. Why don't we really want to use this symbol much anymore?
It might mean X.
Too
Because
crowded.
it might mean variable. It might mean x. Yeah, oh crap. So sometimes you'll see the little dot for times, but here I really don't need it. 2 sitting right next to that parenthesis means twice that thing. Twice that thing. So of course the first thing I want to figure out is what the hell is that thing? So this 2 and that 10 are just going to come for the ride. They can't do a damn thing until I figure out what that thing is in the middle. So they're just going to keep getting rewritten. So twice, and then I'm going to work inside here. Plus 10 is still there. What can I do inside?
6 minus 4.
Yeah, 6 minus 4,
2.
2. And I think I put those first, and you can either leave them in there or not.
3.
3 squared.
2.
Is it cool?
Yeah.
And now I'm still working here because I still don't know what the hell this is.
4.
So twice.
4.
Good. 2 squared means
2
2 times 2.
2 times 2.
3 squared means 3 times 3.
9.
9.
2 times 3 is
No, no,
And
no.
then you put.
This doesn't mean 2 times 3. We already have a symbol for 2 times 3. 3 squared means 2 3's multiplied. 3 times 3. When I see 3 squared, that's 3 times 3.
Oh, okay. So what's ever in the okay? So whatever's down there, that's 2 times that.
Exactly. So this
That
number up
set
here,
itself.
an exponent is the number of these that you have in a row.
Man, I have.
And actually, we're going to talk about that more today.
Ever.
All right, cool. So my favorite noises is, oh yeah, that's what they're. And can I do that doubling thing yet? This thing's
No.
going to be weird.
No.
I still don't know what the hell it is.
Yeah.
Yeah, 4 plus 9 is 13. And do I add or do I multiply?
Multiply.
Multiply. So twice 13.
26.
6.
Plus 10.
36. Cool.
Professor,
I love that.
what if that was a 3? That's 2 squared. What if it was a 3?
3 times.
Here?
Yeah.
Oh, okay, okay. And we're actually, this is what we're going to really focus on some today is exponents. But watch this. Here's the idea, right? So let me. There's 2 ways. Let me come at it this way. We do it a little different than what you asked. I really don't want to. That was exciting. Watch me write that, right? That was
I
awesome.
love it.
So we want to take some of that excitement away, maybe, and make it a little bit quicker, right? So you can imagine. I mean, how many 3's do I have in a row?
7.
Yeah, 1, 2, 3, 4, 5, 6, 7, 8. So there must be a more concise way of writing it. You with me? So actually, let's think back a second. Oh, this is even at least as exciting, Jeff. Did you get 8 there? 1, 2, 3, 4, 6, 7, 8. All right. Can you tell me what that is? What's the shortcut operation to do that? Repeat addition. That's what multiplication is, right? Repeat addition.
3 by 8.
I got 8 3's adding. You guys with me? So an 8 in front, a coefficient, means I got that many of these adding. And then this dude comes along, he says, shit, they already took my shortcut. I just want to communicate to people that I got 8 3's. I don't want to actually write 8 freaking 3's.
Right.
I just want to say something out. But if I put it out front, everybody's going to think I want to add them. So it's like, all right, I'll put it here. No, that looks weird. Here, that looks like 38. Here, there we go. Nothing's up there yet. You guys kind of with me? To tell you honestly, that's not far off from the truth. I mean, when you're working this out and trying to come up with concise ways to write things, it could have been anything. And they just happened to decide to do that. It could have been entirely different. A lot of mathematics that we do could have been entirely different. We just weren't around to make a suggestion. I don't think so. I think it should be a giant 8 with a 3 in there. You know, that could have been the symbol.
Wow.
Freaky. Write that a little better.
It is freaky.
So it really is another language,
Frustrating.
right? When you hear the word merci, if you don't know what that is, you don't know how to respond to that. You're like, are you insulting me? What is that? And of course, it's thank you. But when I see this, I have to know the translation of that, right? So math is a different language. We have to understand what that means. This means that many of these adding. This means that many of these multiplying. That's all it is. Cool. So when I see 3 to the third power, I can rewrite it as
3
times
3 times 3 times 3. And then I can work it out. 3 times 3 is
9.
times 3.
27.
Sweet. So 3 cubed is 27. Does that make sense? Did I go too far? Okay.
I don't know why you, how do you get, okay, never mind.
Which
I
part?
won't miss, the times all of a sudden got in there. I thought it was 9. How do you get?
No. So the difference is, again, if it's a coefficient, if it's a number in front, that means addition. If it's an exponent, that means multiplication. So to get 9, I'd have to have a 3 out front. Now this means 3 3's added.
Okay, gotcha.
3 plus 3 plus 3,
Okay, so the exponent up in the corner, that's multiplication.
that's multiplication.
Automatically.
The
Exactly.
exponent is just telling you how many times to multiply the number by itself.
So in this case,
So
up here I got
there
8
is telling you
3's.
how many times to multiply the 3 by
so you
itself.
don't, but why don't you just go 3 times, but I would go 3 times 8.
Because 3 times 8 isn't the same
So-
thing.
It's not the
Exactly.
same thing. See, that's where I mess up as I go 3 times 8.
So we've already got a way of saying 3 times 8.
Right.
So I'm not going to come up with a different way to say it, right?
Right.
Unless, of course, you're like, I can't use an X anymore. But it's still a basic idea of 3 next to 8 means multiply. That idea has been set. This accomplishes something else. If I've got repeated multiplications, I can use exponents to write it more concisely.
Okay.
If I had 3 to the 86th power, I don't want to write 86 3's down, so thank God some dude came up with this, right? Or dudette, and then some dude stole it from her. Right. Back in the early days, that's the way it happens sometimes.
So 3 times 3 is, 9. 9 times 3 is this, and then that plus times 3 is that, and then
Yeah, so 3 to the 8th is going to get pretty damn big.
it's going to be real big.
Hell yeah. Every couple of 3's is 9, right?
Yeah.
That actually is 9 times 9 times 9 times 9. Yeah. Holy crap.
So is there an easier way to write the number, to figure it out, rather than 3 times 3
No.
times 3?
This is an easier way to write what you mean, but to actually get the number, you do,
Yeah, you have
unless
to
you have a
figure it out.
calculator, of course, that makes everything easier, but to figure out by hand, you got to just do it like that. Yeah.
Okay, hold up. This 3, and then you have the bracket, and then the 3, you said that means plus. Well,
On
we
the
have
bottom.
brackets over there.
No. Here. Why is this? Now, this means multiply. No question asked, right? But multiplication means so many adding. If 2 times 13 means I have 2 13's adding, right?
So I can just do 13.
13 plus 13.
Okay.
I really don't want you to do that. When I say calculate 11 times 28, I don't want to see 11 28s in a row. I want you to do the multiplication. You with me? But realize you could do that. That's what the definition is. Cool. All right.
How I understand it then is an exponent is the number of times a number multiplies itself.
Good. All right.
Is that
That's
what
right.
I'm understanding?
Yes. Exponents are based on multiplication, and coefficients are based on addition. I like it. So, if any of you guys have ever made it to the point where you're talking about the properties of exponents, like sometimes you add them and so forth, they all come from this idea. If I multiplied one more 3 up here, what's going to happen to this? It's going to become 9. So 3
And
times
so on and
3,
so on.
go with me, 3 times 3 to the 8th is 3 to the 9th. Because I have one more 3 in my chain. So what do I do with powers? When I multiply the bases, I add them. Because I'm just adding more stuff in, right? We'll get to that later, it's a little ahead of us. But you can see how the properties come right off.
No, I see it now. I never could get that before.
Cool, I like it.
I was in 90 before I got here.
All right, gotcha. That's one of my favorite phrases right there, too.
Yeah.
I never got that before. But, that's just the basic idea. Once we make ways of writing things, then it becomes, there's maybe quicker ways to do other operations with them.
Yeah.
Okay.
Well, understanding the language. You're making it easy, Jeff.
All right, so far so good. Anything else from that?
Or Mr.
You can call me anything.
Don't go over there.
Call me late for supper, that's right.
28?
28. Oh, yeah, all right.
Oh, man.
So they only give us one side, but they tell us it's a square. So of course the basic definition of square is something where all the sides
Well,
are the same length, and they're at 90-degree angle. Who cares? They're all the sides the same length.
Right.
You don't need. How many perimeter formulas do you ever need to know? It's a trick question. 0. You just need the definition of perimeter. Perimeter is always how far does it get around the thing. So if I have a weird ass shape like this, here's my shape. Here's some building that some idiot constructed. All I got to know is how long is each side and add them all up. There's no formula for this, thank God.
Right.
Right?
Right.
Because I don't know what shape that is. Right? That'd be a long ass list of shapes.
But
Yeah.
when you get into that, isn't the sides are not all even?
I don't care. As long as you know all the sides,
You know what the length
you just
is.
add them all up. So I just send some little dude to walk out there and count them off, and I'm good.
Do a tape measure.
Tape measure, exactly.
Yeah. One guy
The
with a
area.
tape and a nail.
Different.
Area is different. Area is a little more complicated because it's attempting to cover
Yeah.
the surface. Perimeter is attempting to encircle, to walk around. That's why when you hear somebody say walk the perimeter, that just means walk around wherever I'm talking about. And when I'm talking about area, it's like carpeting a room.
Yeah.
Right.
That's different.
So the perimeter here should be relatively easy.
20.
Yeah, 5 plus 5 plus 5 plus 5. And I saw a few people doing 4 times 5, which is beautiful. Because they got 4 5s,
Yeah.
adding, there's 4 times 5, 20. And let's be a little complete here. It's centimeters,
Centimeters.
that'd be centimeters.
Yeah.
Now watch this. The area, I was like this, if I had 5 ice cubes, all right, and 5 ice cubes going this way, then they're all the same size. And I had this whole thing filled up, and I don't want to make you watch me fill it up. If I had this whole thing filled up, how many ice cubes would there be?
25.
25. There'd be 5 rows with 5 in each. 5 times 5. That's why area is basically multiplied. The more complicated your shape gets, you might want to cut
Add
it.
the height with if you add the height of the wall with the length of the wall, then you get a different equation.
Length times width.
Yeah, then you get square footage.
And later we'll talk about, later you'll talk about volume. Filling a room up.
Yeah.
That's where you have 3 dimensions, add in
That's
height.
fine.
But right now, just area here is length times width.
Yeah.
So area here would be. Now here's where I want you guys to be careful. What should the units be? Centimeters squared. Because what is this? 5 centimeters times 5 centimeters. What's centimeter times centimeter? Centimeter squared. And think about this. What shape do I keep drawing?
Square.
Square. So how many squares are there?
25.
25 square centimeters.
Right.
Bam. That's why that's. And volume, I'd be filling up the room with little cubes.
Right.
So volume would be in cubic centimeters. Centimeters cubed. How are we doing so far? We don't really talk about volume besides what I just did. But that kind of makes sense. Oh, okay.
That's concrete work.
Okay. Anything else from that first assignment?
That's it.
Yeah. Oh, good. Thank you. All right. Why was estimation invented?
Make it easier.
Make it easier to do what? To do the operations, right? So I'm not going to do the operations first and then round at the end because that's totally against the whole idea of estimation. You with me? So the idea of estimation is if I have the specific numbers 6289 and 5403 and 1957, and I want to estimate what this is, and I now want to estimate to the hundreds place. So there's a couple of layers on this problem. Do you know how to round? And actually, do you know what the places are? And then you can just add them all up, right? So what number's in the hundreds place here? 2.
2.
And the next number is 8. So we're going to make this become 63, 100.
Yeah.
Yeah. Every now and again, somebody tell me that's a 63. That makes no sense because I wouldn't say 6,289. It's about 63. Nope.
Right. 63G.
This guy here.
64.
Yeah. The next number is 0, so it stays. And then of course this guy here. Okay, this 9. So this this is the weird one. You have to take that up, but the next 100 up is 2,000, right? You can either stay at 1,900 or go up to the next one, 2,000.
So you don't want to raise it.
So the cutoff point is 50, right? 50?
50 on one.
Exactly.
Yeah.
If that next number is a 5 or above, you take that up. If it's a 4 or below, you keep that where it is.
But since that was a 9, you don't put a 10, you raise it.
And it really is just, here's 1957, and when I estimate to the hundreds place, I'm really just asking, is that closer to this, or is it closer to that? And of course, it's more than halfway, so it's definitely closer to 2,000. If it was 1949, that'd be closer to 1,900. I'd round down. How we doing? And now adding this should be a lot easier than adding that would have been. Right? There's a couple. I love the last 0, 0. 7. 13. So 13,700.
I added the whole thing.
All right. So you gotta be careful. Don't add first and then round. That defeats the whole purpose of estimation. It's trying to make the work easier. So don't do the work first and then make it easy. That doesn't make any sense. Okay. Anything else from that first assignment?
Excuse me. She just walked in. I think she needs her paper.
Oh. What's your name? Oh, yeah. All right.
About the very last one. That's what-
Number 30? Oh, yeah.
The very last one. 34 is the last one.
No, the last one I asked you to do.
What?
The last one I asked you to do. This here, right?
No, the one with 10, 20.
Oh, you mean the actual last one?
Yeah.
So I only asked you to go up to 30.
Whoa.
Yeah, I want to see this one though.
But this one?
Yeah.
All right, and then that'll be 34 also. And then we'll get into some new stuff. So one of the first things you learn about variables is the fact, why is it called a variable? Why is it called a variable?
Because you
Its
don't know what it is
value
yet. You have no idea what it
can
is.
vary. Exactly. So the value, I don't know what the value of it is. So all a variable is a number that I don't know yet. Now this problem, I know what it is. X is 2. And let me show you an example. A lot of people don't understand why variables have to be brought in. But I want to be able to write a rule and then be able to change the value of certain parts of that rule, because it depends. If I get paid, $10 an hour, and I work, I don't know how many hours I'm going to work, well, how much money am I going to get? 10x. And then I can just plug in for x, whatever value I've got, right? And then I can make it more complicated. Well, how much tax is going to come out of there is dependent on how much I made, right? So 10x minus a percentage of x. Then I can get a more interesting formula out of it. But without the ability to write an x, there's not a good way to write that rule. To tell people where the x is where you put the value. You guys kind of with me?
Yeah.
All right. So here, all I have to do is do what with this?
Figure out what's
Plug it in.
Plug it in.
Plug it in, right?
They're telling me x is 2. So instead of writing x, I can write it 2. That just goes right in. Now the most common mistake is that third power became a square somehow. Right? And they might have just been writing it down wrong for the paper or something. You got to keep everything the same. The only thing that changes is you put the value in for the variable. Now what does order operations say about this? Yeah, you got to do inside here first.
6.
Careful. 2 to the third would be 2 times 2 times 2, 8.
Minus
2 times 2 is 4, times 2 is 8. Be very careful. It can't be the same value as 2 times 3. The only one that you can get away with wrong is that one. 2 times 2 is 4, and 2 plus 2 is 4. So there's no way to go wrong with that. Everything else ain't going to work. It can't be 6, because it doesn't say 2 times 3.
That's where I kept myself.
So this is 5 times 8.
minus 2.
What do I still have to do? I'm still not done inside the parentheses, right?
6.
This is 5 times 6.
30.
30. Cool. Okay. you guys doing there? Now, I mean, some of you guys might know you could distribute, but there really is no need to do that. I only distribute when I can't do what's inside here. But I can do what's inside there. So I do it, and then I got a nice, easy little thing to do. Right? If you did distribute, I don't know how many guys you know about distribution. 5 times 8 is what?
40.
40. Minus what's 5 times 2? 10. And you still get 30. Right? It's got to be the same, because the distributive property is true. So it's going to make it the same answer. Right? But that's like extra work you don't really have to do. It's easier to do 8 minus 2. Number 34 is sort of like that one, except just sounds harder. And they give you this set of numbers, 0, 10, so on. Now be really careful. Some of you guys probably know how to solve the equation already. Don't. When they say check it, or they give you a solution to try, you plug it in. I don't want to see solving. That's cool, you can do it, but you also got to know that you can just check an answer. So you're going to plug a 0 in and see if it works. And how am I going to know if it works?
Because you get the same answer.
Exactly. I got a true statement. And it wasn't like 2 equals 2. If I get 2 equals 3, that's not the right answer. So that's the whole idea of solving an equation, is trying to get the number that will make that true. So if I plug a 0 in, I get 0 plus 20.
Equals 20.
4 times 0 minus 10. So 0 plus 20 is 20. 4 times 0 is minus 10 is still
10.
minus 10. Is that true?
Yes.
No.
Is 20 equal to negative 10?
No.
No.
It'd be 10.
Not true, and not equal to 0. That's not a solution, right? You guys still with me?
Yeah.
Now let's try 10. You guys try 10 out.
So you go to the next.
Don't say anything. Oh, I'm sorry. Go
You
ahead and
to
try
the
it.
next- You go to the next number.
Exactly. Until you get the one that works.
Okay.
So try out 10 on your own. So this is the rule. This is the rule. If I think n equals 0 is an answer, I put a 0 in for n, but it didn't work. It's not true. If I think n equals 10 might be an answer, I plug a 10 in for n. And then I see if it comes out true.
It's incorrect.
Yeah.
10 is
So watch what happens. So in this rule, here's the rule again.
10.
But I know for the moment I'm going to let n equal 10, because I can make it equal whatever the hell I want to. So I'm going to let n be 10. So here I get 10 plus 20.
Plus 20.
4 times 10.
10 minus
So see, all I'm doing is replacing n with 10. I'm leaving everything else the same.
30.
So here I get 10 plus 20.
30.
Here I get 40
40
minus 10. Check. N equals 10 is the solution. Now you can try 20 out, but you already know it's not going to work, because we'll find out later that when I have an equation like this, where the power on the letter is 1, there can only be one answer at most. There actually will be, well, let me say the whole story. There could be one answer, there could be no answer, or there could be an infinite number of answers, right? So we'll get to those special cases later. Normally there will be one nice little answer. Okay, the other 2 things are a little freaky. You guys feel okay about that? I mean, this is going to come a lot more in play in chapter 2, when we start to focus more on solving equations. Yeah. This is sort of like a little precursor to that. Okay. So tonight I want to finish out chapter 1. So I want to do 1:7 and 1:8. And let's see.
So, Mr. Waller, I don't have that book yet. And I don't have the
That's all right. I made copies. But I might put it up here to use. See how this goes. guys are going to lecture for a little bit, and then I have copies of the problems I want you to do. So I'll pass that out if you don't have your book yet. How many guys have the blue book tonight with you? All right, so hopefully I made enough copies. We'll find out. Never know about this technology. It likes to mess with your head.
You can turn the light off.
Yeah, well, I think it gets decently.
Like
Right.
Jack Daniels.
Why not?
Yeah, it's good.
Like Jack Daniels.
It's coming, huh?
Yeah, no, it is Jack.
You never know.
Jack and Juice.
Whatever gets me through. No, I'm a Georgia boy. This is definitely sweet tea.
Makes them a better teacher.
And they have the purple one. You know what the purple one is?
No.
The purple label is the little tea with your sugar.
Kool-Aid.
They're like,
Yeah, I know that one.
That's the tea I always used to drink.
Mushroom tea.
Yeah. There we go. All right.
Korean large.
Is this from the blue book?
Yep. This is page 8.
Maybe a little bigger, please.
Yeah, I will. I think I might want to shut out one light.
There you go.
And I'll zoom in a bit, don't worry.
Did you say page 8?
Page 8.
In the blue book. She has paid first for us.
Oh, yeah.
Page 1.7.
All right. Okay. So let's see how this works out. I don't know. I used this before in my class and it worked out okay, but it's not my preferred method of doing this. But this book makes it possible a little easier to keep up track of notes since a lot of it's already written. You just have to fill in a little few blank areas that we're going to work out together. And then it's got a lot of practice problems that we'll do together, and then it's got problems you do on your own. And then we talk about. So it's not a bad setup. It's just every now and again has interesting ways of spelling things. That's probably because it was put together by math. So the very first thing is, this is what we talked about earlier. And it really is true. It was just, and I often say it's just because we were lazy people, but lazy math people. But it was just a better way of writing a long list of numbers multiplied, is to use the idea of an exponent. So if I have 4 times 4, that's 4 squared. And if I had an exponent of 1, what would that mean? Like if I had 2 to the first power.
It's two.
Two times.
It's just 2.
It's just
Why
This
do
is-
we even do that?
Exactly. We don't.
I mean, why even put?
So if I don't see anything, if I just see a 3 sitting there, what does that mean the power is? It's a 1 power. Now why do I really want to make that point? Because a 0 power means something else. We're going to get there eventually. Right? So some people get a little confused. They think there's a 0 up there. No, there's an understood 1. If you really want to get crazy, if I see a 3 just sitting there, there's an understood 1 there, then there's an understood 1 out there, there's an understood 1 underneath there. Thank God, those are all understood, so we don't have to write them all out. You with me? Is that cool? Okay.
Zero N is my favorite.
So here one, if you have an exponential expression, so if I have something like 5 cubed, how would you write that out? What would that really mean? 5 times 5 times 5. Now, how do you work that out?
5 times 5.
Yeah, 5 times 5 is 25.
5 times 5.
Exactly, good. 25 times 5, 125. Right, I love it. Because 4 quarters would be a buck, and 5 quarters is another quarter, but beyond a buck. So 125. Cool. What about this? Let me give you one a little bit different.
Okay, that's 2 times 3. So those powers time each other.
Yeah, be careful.
Okay,
It's 2 times 2 and 3 times
2 cubed is 2 times 2 times 2.
8 times.
Good. 8. 3 squared is 3 times 3. 9. 8 times 9? 72. I love it. Cool.
Got it.
All right. And again, I want to say this again. I'm going to say this every now and again. A lot of you guys have very different math backgrounds. Some of you guys right now are like, okay, dude, I know this stuff. So just hang out, stare at the wall, appreciate that you know it currently because you're going to hit something you don't know soon. If I go too fast, slow me down. If I'm going too slow, deal with it. This is where we get really evil kind of problems here. And look what it is. It's a very simple little phrase. An exponent applies only to its base. So how could that be evil? Jumping ahead a little bit. If I saw 2x squared, so I've got this variable squared. What's being squared?
2.
The 2 for 2.
The 2x.
X.
So an exponent can only apply to its base.
X.
What I always see though is somebody tells me that this is 4x. And you see what happened. That 2 somehow got really lively and jumped over. But this means 2. How many 2's do I have?
X
I have 1, 2.
We got 1.
times
Times
X.
a couple x's. So if you really wanted to write this out, what would this be? If I wrote it out in expanded form? 2, 11.
Times X.
X. Is that cool? You can see that?
Yeah.
So the power can only go so far. And here's the most evil example of this. And it's only evil until you see it's not evil. You gotta be careful. So I want to show you now before it gets you later. If you see this, there's a difference between this and this.
Outside and inside.
So which one of these has 2 negatives? Which one of these is the exponent applied to the negative also?
The top.
Bottom one.
So in this top one, what's being squared? The 2. That's 2 squared with a negative sitting out front.
Right.
So what's 2 squared? 4. So the answer is -4. Because that square can't get over there. It can't.
Can't do anything.
Powers are very weak. They can actually just get parentheses help powers reach everything.
Oh.
What's being squared here?
It's
The whole damn thing. So this first one, you would write, there's 1 negative, and then there's 2 times 2. So that's -4.
Right.
The second one, what do I have 2 of?
You have
I have
minus
2 negative
4.
2.
Minus 4 twice.
Careful.
So it'd be -8.
No, come on now.
Positive.
Yeah, you got -2 twice.
Positive 2.
The 2 negatives.
Oh, it's a positive.
Guys, it's just.
A negative and a negative.
So the 2 negatives,
Would be
cancel.
positive.
Yeah.
And 2 times 2.
It's
4.
11.
That's right.
And a real quick word about that, because what happens when you add 2 negative numbers? They stay negative, exactly, because the negative numbers are like owing money. So if I said something like, I'm running out of room on that page. If I said something like -5 minus 6, I owe somebody $5 and I owe you $6. Well, how much money do I owe altogether?
Negative
11. So I owe $11. Right?
Right.
You with me so far? So the shortcut rule is if the signs are the same, you add them. 5 plus 6 is 11, and you put the sign back on.
Right.
If the signs are different, you subtract them. 8 minus 5 is,
3.
and you put the bigger sign on. So that's positive.
That's plus 3.
If I owe you $5 and I find $8 on the floor, I can pay you off and still have $3 left over. That's what that means physically. Right? I used to talk about this like filling in a hole. If I had a 5-foot hole and I put 8 feet of sand in, but money we can all relate to, right?
Yeah.
Normally that's the way it goes, but
Well, I don't know how to relate.
it goes out, not in. We can relate to.
Money. Somebody listen.
And here, just to make this very clear, order operations, right? Parentheses, and actually they talk about grouping symbols because remember brackets are just another symbol for parentheses. So parentheses, exponents, multiply or divide as it comes, add or subtract as it comes. That's why I write it like that, right?
So why do they want to trick us up with brackets and then the freaking...
It's just because, can you look at this expression here?
What's that sweet Aunt Sally crap then?
I mean, look at that here. Look at this. This is a little difficult to follow.
Oh,
If I just made this second thing a bracket, and made this last thing like a little squiggly dude, it's a little bit easier to see who goes with what.
Oh.
That's the only reason they do that. They're not doing that because they're like, all right, how else can we make math more
Screw
difficult?
these guys on.
Right? It's really just so that it's easier for the eyeball to see what goes with what. That's purely the motivation. Okay. Yeah, the please excuse my dear Aunt Sally thing. Or please excuse my dumbass son. PEMDAS.
That's son. I like that one better.
Alright, so you use that one. It's just a little mnemonic device to remember this. PEMDA. If you do music, every good boy does fine. You guys know that? Is that the way it is?
What is
I obviously don't do music.
That's me.
Just remembering the chord,
Yeah.
not the chords, but yeah. And then face is
The
the
order
other
of
ones.
things.
Alright. If you don't do any music, you're with me. I can barely remember that because I don't really play it. Alright, so let's try this here together. And then we'll let you guys try some out on your own. And also, I'm going to try to keep an eye on the clock better than last time, because at the end of class, let us out early because we're all going to take that field trip I was talking about.
Oh, yeah.
And at the end of the field trip, you can just head out wherever you want to go. The class will be done. Let's try these together. Let's try a few of these, and I'll let you try a few out on the next page. How would I do this first one here? By the way, be very careful about if they mean multiply or if they mean decimal. So in this case, on this first one, what do they mean?
They want 6 times 4.
Yeah, they mean multiply, right? It's not 6.4.
No.
So what would you do? What operations are in that statement there?
6 times 4.
Subtraction?
6 times
Yeah.
4.
Six times four first.
Good. So you definitely want to multiply first. You would subtract at the end. So I got 32 minus stays there. 6 times 4 is 24. I love it.
So then you minus.
And then 32 minus 24, 8. Sweet. Let's try this one here because it looks a little funky. It's got a fraction kind of thing. What would the last thing to do be here?
Divided by 3.
Okay, that big division bar is the last thing. I've got to do the top
Subtract.
and the bottom, and the very last thing I do is divide those. Now watch this real quick before I get into doing this. If I wanted to write this out in a row instead of on top of each other, this is not right. Why is that not the same thing?
Because you're only dividing 7 by 3.
Good. This only says 7 divided by 3. What do I want to divide by 3?
The whole problem.
This whole thing. Cool. So if you wrote it out in a row, I'm losing the big bar that naturally breaks it up. I have to put parentheses, or in this case brackets, to break it up for me. So this way is actually a little better. I can really see what's going on. So on the top, what would I do first?
6 minus 2. Yeah.
Good.
Minus 2.
4.
So you write 5 times 4 plus 7. Everything else stays the same.
5 times 4.
Good. Multiply before you add.
Yep.
So 20.
20 plus 7.
27.
27.
9.
Divided by
Love it.
3.
It's not. And let me, to piggyback off the earlier statement I made about all the different backgrounds, do not let me steamroll. Do not let me do a problem quicker than you wanted me to and not say a word. Because if it's quicker than you wanted, it's probably quicker than 10 other people wanted to, and you're just all being quiet. So you could be 10 people's hero if you just raise your hand and tell me to slow down.
You didn't bring down the brackets. How come?
You don't have to.
You don't
Oh.
have to. Once you do that problem, they disappear.
So what I did was, if I wanted to rewrite this problem in another form, I would need to have the brackets.
Right.
The big bar does that for me. The big bar
Like the
puts the
bracket.
top and bottom separate.
Separate.
If I wrote it in one line, I need the brackets to make the top divided by bottom. Does that make sense? So the problem I did, I just did it straight off of here, so I don't need the brackets at all. I just use the big bar to separate. Cool. Let's see, let's jump ahead a little bit. Well,
Question.
yes, ma'am.
Can't you reduce it?
Right here, 27 over 3.
No, I mean the 9. Could you reduce it, or
How do you mean reduce it?
like since 9?
To a simple form?
Yeah, to a simple form.
No.
Simplifying it.
9 is a simple form.
Only if it was, right now, what's it understood to be over? This is 9 over,
1.
understood to be 1, because there's nothing really down there explicitly, so there's nothing else I can do. 9 divided by 1 is just 9.
Okay.
Now, if I got an answer like 8 over 6,
Yeah.
and of course I'm getting a little ahead of myself because fractions are coming later, but Why is that not quite right? Even if you did all the work right, I'm still going to take a point off
Because it's an impossible.
It's not equal.
because I haven't simplified it. Right?
Simplified.
What goes into both of these still?
2.
2. So I can make 8 divided by 2, 6 divided by 2.
Yep.
Right? Now, if you're not all that great with fractions and you're like, I can't remember what the hell just happened, don't worry. We're going to focus on fractions later. But that kind of was like what you're asking.
Yeah, I was just trying to.
This is a nice whole number. I can't take it any further. Yeah. It's just 9. That's it. All right, now to be really, really evil, see what you can do with number 5.
8 minus 5.
So I think Lucas eyes are going. This is always the way we math teachers do this. We do the easy ones, then we make you do the hard ones. But what are the last 2 things I'm going to do here? What are the last 2 operations? Yeah, which would be more specific? That 30 minus
Subtract.
and the plus
Not last.
Plus
2 times 3, which is 6. So I'm going to do those last.
Last.
Because the whole middle part's in brackets. They get done first. So inside here, what do I do first?
8
minus 5.
Good. 8 minus 5 is 3. Whoa, this really feels hard. Inside here, what do I do next?
16
Yeah, 4 squared. I do exponents next, right?
16.
So 30 minus, be careful, it's not 4 times 2, it's
4 times 4
2
times
4
4s.
times 4,
4
right?
times 4.
16.
Yeah,
16.
So 16.
Plus 3.
What is this, by the way?
2 times 3.
6. So 19 minus.
So 30 minus, what do we get inside here?
13.
Yeah, 19
19 minus.
minus 6, 13, is that cool? Yep, let's do that.
What do you got, where's 19?
16.
16 plus 3,
Oh, minus 6.
and then minus 6, yeah,
It's 13. Okay,
13,
got
yeah,
it.
cool.
So 5 is about 5.
So now what do I do? Would I do 30 minus 19? Is that 30 minus 19?
11 minus.
I've made a mistake.
30 minus 3.
It should be 30. What do I do first now? Do I do 30 minus 13 or do I do 13 plus 6? What do I do first?
13 plus 6.
13 plus 6.
Nope.
30 times.
When you have addition subtraction, you do it
And the order.
as it comes.
Okay, first.
Yeah.
30 minus 13,
17.
17, plus 6,
No.
23. Oh, plus 6.
23.
That's
If it says minus 6 up there, why did you do plus?
Oh, okay.
Yeah.
All right, I got you. What I did was I did this whole inside See that plus 6? See where it came from? Plus
You
6,
brought
plus
that
6,
down.
plus 6. That's where it came from. That's the plus 6 there,
So
right?
you just brought it down.
That's been there from the beginning, the plus 6. What's the inside? 16 plus 3
Minus 6.
is 19. Minus 6 is 13.
Plus 6. You just keep bringing it down.
All right, so let me do that one again. Zoom out a little bit. All right.
I got that.
So we're all cool with the first step, which was the 8 minus 5.
Move it over.
Yeah.
Oops, sorry.
Nope. Open the front. Oh, there you go. Perfect.
All right. Now inside here, let me show every single step here. I definitely have to do exponents next, right? Please excuse. So 4 squared, 4 times 4.
16 plus 3.
And see how the 30 and the 6 are just coming for the ride, because they can't do anything until they know what the hell the middle dude is.
That's right.
So then I get 30
It's like
minus 16 plus 3 is 19.
Minus 6. Minus 30.
And 19 minus 6,
You got your brackets.
13. So I didn't make minus 6 become plus 6. I just brought the minus 6 and the 19 together. And then 30 minus 13
Yeah.
is your 17.
Yeah.
Plus 6 is your 23. Cool. So the better you are with order operations, you should be able to do more than one thing at a time. The less comfortable you are, the more you should just do one thing at a time and rewrite everything else until you get to be more comfortable.
The more you do it, the easier it's going to get.
Exactly. And I don't care how comfortable you are with it, you better show me some work,
Yeah.
right? The mantra of this class is show me work. Right? Now that doesn't mean if you say 2 times 3, don't be a smart ass and say, all right, John, I'm going to show you the work. We know 2 times 3 is 6, that's fine. But in general, when you're in doubt, show me some steps, show me something. Okay. Let's go ahead and do this here. If you got the book, it's page 10. And I really just want you to do, cut this down a bit so I can get through this. Do the first 2. Do 4, 5, 6. I got copies of this, so don't worry, I'm going to hand it out. Do 11, 12, 17. That'll be good for right now.
Do you want us to turn this in?
No, we're going to go over this so you guys can have it in whatever form you want for yourselves. Who needs a copy of this? When I come to your row, let me know. You need a copy. Anybody else? Yes. Oh, yes. You good? You guys need anybody here?
Oh, yeah. 1, 2, 4, 5, 6.
That's probably 4 there. That's perfect. All right. Cool. I wish I could say I planned on it, but huh?
Top of here. Got a new son in Italy.
And you guys.
Oh, you're doing it. That's
So again, let me write it here.
What does it mean when you have evaluate? What's the difference between evaluate, simplify, and the word?
They actually pretty much mean the same. Evaluate normally means plugging something in for a variable, so they sort of chose the wrong name there, but it still works. Evaluate means simplify. They really mean the same thing.
Oh.
Yeah. So let me just put it up here. The ones I want you to do.
Oh, I thought you were.
1 through 6. I like that they don't have a number 3.
No, it doesn't.
Oh, yeah. So Don't forget, if you did your learning style survey, if you have those, you turn them in.
Here.
Turn it in on the way out if you want to. That's right.
And can you refresh my memory where you go for that? Like where you go?
Off the website, there's a link, the very first or second link. They're the top two links are the surveys. The information survey and then the
Okay.
learning styles survey.
And that's www.grossmont. And then your last name.
It's grossmont.edu/Jeff Waller.
Okay.
It's up on the top of the syllabus.
Okay, okay.
It's perfectly fine to work with people near you if you want to. You can call me over if you need some help. Oh, did you? I didn't give you a copy. I think it's most of them there. Oh, do it all the way out, so figure out what that is. What number is that?
Okay, so maybe I need some clarification. So are we supposed to be writing it like this, or even if this is right, like
I love it. And then put a little dot in the middle for me, that means times. There you go. So you got 3 4s multiplied by 3 3s. I love it.
Okay.
And that's it. Yeah, and we're done. That's it.
That's
number
that.
one.
That's
Mhm.
it. Okay. 21 2
Good. I love it. Now what are you going to do? Add or multiply next? Good. 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 There's another one, but maybe everybody's got one and two. I like it. Hey, to get done early, quick, do them all. Yeah. Some more fractions? Oh, you are, oh. But no, then. Get ahead.
Yeah.
Yes. So how would you do that? Good. Times, we'll dot it. What's that? Yeah, you can only collect like bases. You can only collect the bases that are the same. You have 3 4s and 3 3s multiplied. That's exactly what you've written there, right? 3 4s times 3 3s. Yeah, and the exponent is just a quicker way of saying how many 4s do you have multiplied. So I got 3 4s. So that's a really quick way to say 3 4s times 3 3s. Yeah. But you can't put like 4 times 3 is not, you know, what would that be to the what power? I mean, you can actually multiply it. That's 12, but you can't like put it together in exponent notation, right? It's not, 4 times 4 is 4 squared. 4 times 3, they're not the same. You can't consolidate. Yeah.
Oh, I got you 4 times 2. Okay, plus 12, I like it. 15 minus, say, 15 times 33. So the mistake here is you do this as it comes. So 50 minus 33, and then you add in 12. You have to do this as it comes. So you do 50 minus 33.
I asked this, last period, I asked you if you first make this first and this.
No, so it's as it comes. As it comes. You just do it as it comes. So here, addition, subtraction, you do it as it comes.
This first?
So you do, the subtraction comes first, you do that, and then you do the addition.
No, this
Because, I'll show you when we do it. I'll show you a nice way to realize why it's got to work that way.
because I read inside and up.
Gotcha.
Outside.
Yeah, but you got to do it as it comes. As it comes. And hang on. I want to show everybody at the same time. There's a nice way to look at it that'll make it make more sense.
So you want us to solve this?
Yep, good.
This rate is 81. But
That's it?
yeah.
Or right here. 5 squared. 2 times 5 times 5. Yeah. No, that's good.
Is that 1 or 10?
Yeah, so 25 sitting out there plus 4 times 2, again, 4 times 2. That's why it's really difficult to do parts of it and try to bring it back together.
Yeah.
You gotta maintain, you gotta rewrite the whole thing to really see what comes next. Oh, that's I plus.
I thought the same thing.
Definitely didn't say the minus.
Oh, because it's
Actually,
only
if it was a
asking for
division,
one.
you would do 5
Yeah,
times
it's
4
asking for you to
first,
multiply
and then
1 by
minus.
itself, 10
You
by
do it as it
itself,
comes.
which means nothing, because it's 1. 1 times 1 is 1.
Got it.
I thought the same thing.
Got it. I just got it.
right, guys, let me catch up to you here. Now, on this first one, if it was just that, how would you rewrite that? 4 times 4 times 4 is 4.
Yeah.
Four
Yeah,
to the
you-
fourth.
4 to
Three
the
to
third,
the fourth.
4 to the third power
and 3 to the third.
times.
Three to the fourth.
So you just consolidate what you can.
1,728.
Let's not do that.
Oh.
So we just need to stop right there. So be real careful. They say just say using exponential notation. So I don't need the numbers. When they say simplify or evaluate, then I need the number.
Give me the
Oh,
answer.
okay.
When they say rewrite in exponential notation, you can just stop at exponential notation.
I didn't see.
What about number 2?
21.
21.
Four.
11. Cool. You got 4 21s multiplying, so 21 to the 4th power. 11. So what about number 4? Yeah, I love that. You got 181, so you got 181. Sweet. Number 5?
3 to the 4th power.
Yeah, so that you can rewrite as you got 4 3s multiplying. 3 times 3 is 9. 3 times 3 is 9.
81.
Exactly. Right?
Yeah, 81.
You don't have to do that. We can do 3 times 3 is 9, times 3 is 27, times 3, and you do that, you get 81. Whatever way you do it, it's got to come out to be 81. Cool. This one freaks people out sometimes, but it's almost too easy.
One.
Yeah, 1 to any power
10.
is
One.
careful.
One.
It's 10.
No.
It's 0.
What does 1 to the 10th power mean? It means 1 times 1 times 1 times 1 10
And it's always
times.
going to be 1.
It's always going to be 1. I don't care how many times you multiply 1 by itself, it stays 1. It's not 1 times 10. It's 1 times 1 times 1 times 1, and you'll always end up with 1.
Alright.
So 1 to the 18 billionth power is 1.
1.
Poor little dude never gets anywhere. What about number 11?
That's 8 divided by 48.
Yeah, you got to do the division before subtraction.
Yeah.
So 6 minus 2,
Yeah.
4.
4.
I kind of wrote over this poor little 2 dude, but on number 12, what would you do last? Add last. You got to multiply before you add, so you got to multiply here and here. 2 times 5 is
10.
10 plus
24.
24,
34.
34, 11. So see that whole idea of looking and just telling yourself real quick, what would I do last? That'll keep your focus. And you know if you do that somewhere, you're like, I was supposed to do that last. I wasn't something wrong. What else did I ask you to do?
17.
17. Let me write that up here because it's a little involved
You
here.
know, is it ugly?
Is that 50? I kind of wrote over mine.
Going cricket.
Yeah, I know. I do that. All right.
So parentheses.
So you definitely have to do all of this
Yeah.
first. Those brackets kind of group all that. The 50 and the 6 times 2 is just going to come to the right. In fact, 6 times 2 is 12. So that 50 minus and that 12 is just going to come to the right. What do I do first in here?
Parentheses. 12 minus 8.
5 squared plus
6.
4. Right, 12 minus 8 is 4.
Yeah.
So then the 50 is still coming.
Yeah.
Yeah, do exponents next. 25. And you guys, and now I know it seems like a waste of time to keep rewriting it, and the more comfortable you are with this, the less you have to do that. But you gotta rewrite the whole thing so you remember what goes next. If you try and do parts of it, that's when you start adding before you multiply. That's when you start making mistakes like that. But just carry everything for the right. Change one thing. What do I do next? And multiply before I add. 25 plus 8.
Plus 12. And then 25.
And I'm not done in here yet. Good.
3.
Now, answer me this. Is that, which number is negative in that statement? 33. So that tells you why it doesn't make any sense to do 33 plus. I don't have 33 in there. I do not have 33. I have negative 33. So if you wanted to do this first, you actually could, and this is why you can break order operations in a sense if you're more comfortable with how things work. As long as you do negative 33 plus 12. I really don't feel like doing that. So I just do it straight. Order operations officially says you add and subtract as it comes. So what's 50 minus 33? 17. So that's here. 17 plus 12, 29.
What were you at?
You're good up to here?
33 plus 12.
Definitely not. I don't have a 33.
Oh, okay,
And this is where some students are like, okay, this guy didn't take his meds.
33 minus
There's a 33 right there. It's a negative 33, right? So adding 33 to 12 would never make any sense because I don't have a 33.
Is that a negative 17?
It's definitely not, because which one's bigger?
Oh, the 50.
The positive 50.
Okay.
So I got $50 and I owe you 33. I'm still going to have 17 afterwards. I'm not in
For
debt.
some reason I thought the 50 was a negative.
If I put the 12 plus 50 is 62 minus
That'll work too.
33. Work.
So again, the more comfortable you are with the rules, you could do 50 plus 12 first, and then subtract 33. Nothing wrong with that. And that's a property called commutativity, where you can move certain things around. You only want to do that the more comfortable you get with what you're allowed to do. You with me? So I'm showing right now, I'm showing you by the book exactly how to do it. There are shortcuts and other ways of doing things, which if you're more comfortable and you know them, go right ahead. Just make sure I understand what the hell you're doing, because you make a mistake and I don't know what you're doing, I got to take off more points. I have no idea. So you got to show me what you're doing.
Your little thing is off, like,
Oh, is he off?
it's like on, but it's like,
Poor little dude.
freaking,
Oh, that's not too bad.
no?
Yes, I can see that.
Good? Yeah?
Yep.
Looks like all freaking,
That's because this is crooked.
oh, okay.
All right. Cool.
All right.
So last little bit here, and then we'll go on our little field trip. This is where we officially get into variables.
I hate those stupid variables.
Why is that?
Because they're letters, like, stupid letters.
So, what variables are trying to do is, instead of having an empty spot, we pick a variable. Because if I, if I get, I work 2 jobs, and I get $12 an hour at one job, and I get $9 an hour at the other job. Right? What is minimum wage now? My first job, I made $3.25 an hour.
Yeah, 335 is what I made.
Right? So $12 an hour there, $9 an hour there. But I don't know how much I'm working at either job. Let's say this is job A and this is job B. Well, how much money would I make at job A? Well, I don't know how many hours am I working there. Let's say I'm working, if I'm working A hours there and B hours there. Now let me stop right there for a second. Why do I have to have 2 different variables there?
Because you worked 2 different number of hours.
I don't have to work the same number of hours. They could be different, right? If I said this is X and this was X, they'd have to be the same number of hours. And we all know that ain't true, right? In fact, poor me, I probably get fewer hours there than I want because I'm getting more money there, damn it. That's a lot out there. So how much money would I make total here? Kind of a weird question right now. What if I work 2 hours there? How much money would I make? $24. What did you do? Number of hours times money per hour, right? So what if I work 8 hours?
8 by 12.
8 hours. So that would be 12 times 8. Plus, how much do I make here?
9 times B.
9 times B. Beautiful. So that would represent my total income for that week. If I knew how many hours I worked at that job, how many hours I worked at that job. Now, if I didn't have the idea of variable, I couldn't even write that expression. And a lot of us, and I totally understand this, because the next thing I would say if I was in this class, being the smartass that I am, I'd say, dude, I know how much money I'm making. I don't freaking put A's and B's down there. What the hell's your problem? Right? And I totally relate what you're saying, but in reality, we have stuff like predicting the weather. In San Diego, we had, you guys realize there's a tropical depression working its way up past Baja, California, and they think it's going to kind of, the remnants are going to hit us early next week?
Yeah, right.
Well, you never know.
Yeah, it does.
Whatever they say we're going to get, we're definitely going to get less.
Yeah.
Pretty much is the standard rule I figured out. But how many variables do you think goes into predicting the weather?
A lot.
there are a lot of equations. In fact, when you see a weatherman's report, they have about 23 different models. All these different equations that use different variables. The variable could be temperature of the water, wind speed, how much moisture is present. So all those are variables. So that, then you tell the computer, put the right values in for today. So the computer puts them all in. Into the right place, because it has the variable there. It's defined in the computer program as a variable, so it just puts it right where it's supposed to go. If I couldn't tell the computer X is here, Y is there, X means water temperature, Y means wind speed, how would it know where to put anything? And that is not something I could just go, just as easy as how much money I'm going to make. I'm not going to go, well, let me just figure the weather out in my head. No, screw that. Right? I need to set up an equation with well-defined variables, so I know exactly where to put the values. You kind of with me? So, I mean, this is the beginning. This is where we start to do problems like this, which it's really rough at the beginning because you're like, I don't need to set up an algebra to do that problem. I don't need algebra to do the problem. But you're trying to get used to algebra. So what kind of problems do we want to start with if I'm trying to get some algebra understanding? I want to start with something I can do already. So I already kind of know the answer. So then I can kind of practice with the algebra and feel a little more like there's a safety net.
Okay.
You guys kind of with me? So the problems you work with very often in this class are going to be simple. You might have another way to do it, but that's why we make it simple, is so you can practice the algebra.
Okay, so
And not just be stuck on the hardness of the problem.
That's it. That's the answer.
What's up? Oh yeah. So that would be, then I could come along and say, next week I'm going to work 10 hours there and 12 hours there, and then I plug in the values in the right place. Is that cool? Okay. Okay, maybe. Let me see. So up here, and I think I said this earlier, when you see two things sitting next to each other, that implies multiplication. So if I just write AB, that means whatever A is times whatever B is. You guys with me? So what's a better way to write something like A times A? A squared, I love it. What would A? I love it, sweet. So, right? So that's, when it's sitting next to each other, it means multiply. And here's an example of what I was just talking about. They have a formula, an expression, right? X plus Y. And I have no idea, what is X plus Y in general?
We don't know yet.
Orange. I don't know what X plus Y is, Jeff, but the minute they tell me what X is and what Y is, I can of course figure out what it is for that example. So if X is 5 and Y is 2, put a 5 in for X, put a 2 in for Y, 7. And this is really the right place to use the word evaluate. So I'm glad, I think it was you brought that up. This is really the correct place to use the word evaluate, because that kind of means plug stuff in and see what it would be. Okay. So we have an expression. An expression is something that does not have an equal sign in it. So this would be an expression. Whoops, there we go. That would be an expression. An equation, of course, has to have an equal sign in it. So if I had X plus 5 equals 8, that's an equation. Cool, so that's the difference between those two. Which one will actually have an answer? The equation will have an answer, because that equals is a specific situation. There's only one X that will make that true. And of course that X would be 3. 3 plus 5 is there. So as a specific answer that will make that true. X plus 5, there's no requirement. It's just X plus 5. What's X? Whatever the hell it wants to be, right?
It's just the beginning of something.
Yeah, I have no specific requirements. Here it says X plus 5 must be 8. Okay, now I should be able to get an answer to see what would make that true.
Expression is a piece of something, not the whole.
It's one way you can look at it, but an expression could exist by itself. It doesn't need an equation to mean anything. It should be able to exist on its own. An equation is you set two expressions equal to each other.
So now, what use is an expression?
Like up here, an expression could be like this. This expression represents your income, which
Oh, I see.
So,
I'm not going to set it equal to something, and I could, if I wanted to set up an equation and say, all right, I need to make $400.
I want a TV.
Huh?
I want the TV.
I want the TV or whatever the hell. And I know I can work 13 hours there. I can try to solve the equation now for A. How many hours must I work there to fill out that $400? You guys kind of with me? That's when I have a requirement. I've put an extra requirement on this expression. I want it to equal $400. By itself, it just represents my income, and I can put things in for A and B. If I make it an equation, I can figure out what they have to be to make that true.
Okay, so an expression is just a part of an idea or a part of something that's going on.
It can represent something. And then if I want to know, I want to make this happen, that might lead to an equation.
Right. Okay, got it.
Good. All right.
So you could have like a whole string of X, Y, Z.
Yeah, so I could have
But as long as you don't have that equal
3A
sign,
plus 9XY minus 2.
it's an expression.
D plus 7 over W. That's an expression. There's no equal sign in it.
So as soon as you add the
Right.
equal sign is when it becomes an equation.
Exactly.
Yeah,
Cool.
we gotta figure it out.
Exactly. Good. Blah, 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 blah. And we've already seen problems like this. We did one like it just a minute ago. But that's why I didn't assign it, was because it was the next section I was going to cover. This is like that problem that had 0, 10, and 20 with the ends. The equation, I had to see if it was a solution or not. So is -2 a solution to this? How would you find out?
Do the problem.
write it out.
Now, I need something a little more specific than do the problem. Plug it in, right? Plug in a -2 for what?
Why?
For y, that's my variable. That's what I can control. So if I plug, so twice y, I'm going to let that be -2. Plus 1, is that -3? What did you do here first? Yeah.
Yes.
Multiply. 2 times -2 is... Oh, sorry.
Sorry, but you add the parentheses on your own so that whoever reads it wouldn't think it's 2 minus 2?
Exactly, because if I rewrite twice, I want twice y, but if I write that, it looks like 2 minus 2. So in general, when you substitute a value in, you almost always want to put it in parentheses.
Separate part.
If I don't, what does this say has to happen between 2 and y? What operation? Times. But if I write 2 like this, that's subtraction. Now I've totally done something opposite than what that tells me to do. So I'm not going to get the right answer. Yeah. So when I plug a -2 in, I better still be multiplying these two things. Because what's the rule say I have to do? Multiply. 2y. That means multiply. I like it. So you almost always, when you plug stuff in, you might want to put in parentheses always. Then it's always going to preserve the operations that are happening. And then 2 times -2. And -4 plus 1.
3.
Good, so that works. So then -2 is a solution to this equation. It makes that equation true. That's then I call it a solution to. Cool.
Maybe a silly question, but if we solved it like that, you'd be able to see, like, we literally don't have to write yes, right? Nobody knew that.
So again,
We literally don't have to say, like, yes, like, when we solve it, right? You'll see it, right?
oh, if you put a little check mark, I'm cool with that.
Okay.
Or you put a yes, or you put a solution or something indicating that it worked. So a check mark means it works. Good,
Okay.
right? Now if it doesn't work, you just write not a solution. Yeah. Or a little X mark or whatever the hell. Yeah. Something that indicates it didn't work. You guys try this one. And you always, when you rewrite, when you plug something in, you want to preserve everything. So you have to have a 5 here, the -1, the equals 30. I'm going to plug a 6 in. And what's the operation here? Times. So I want to put parentheses. So that means times. If I just put 5, 6, well, that's 56.
We don't want that.
Shit. All right, at least do that, but it's even better to put parentheses. And then, how do I do this side here? Yeah, 5 times 6 is 30.
Minus minus.
And that, of course, already tells you ain't going to happen. 30 minus 1 is 29. No. Not. Don't, no, let me say this. Don't put no solution. We've only checked one number out. I don't know if there's no solution. All I know right now is that is not a solution. There is a solution to that equation. I just don't know what it is. I know it's not 6. So the answer there should be not a solution. Don't say no solution. Do you see the difference?
Yeah.
If you say no solution, you're like, I looked at one thing, but I know it doesn't work anyway. I can't say that. All I know is that 6 is not a solution. There is a solution to that equation. It's nothing pretty, but there is one. Alright, so I'm kind of figuring out how far I want to go with this. Real quick. Well, I just want to point this out for right now, and then we're going to go on a little field trip. We'll finish this up next time. This table is not too bad. It kind of shows you the main words that mean these things. So if you see any of these, sum, plus, added to, more than, increased by, that means addition. So if I said a number increased by 7, how would you write that?
Plus 7.
Addition.
What plus 7?
X plus
I
7.
love X plus 7 because you don't know what the hell the number is.
Right.
Don't pick a number. Don't say 5 plus 7. Then I'm like, where the hell 5 come from? A number increased by 7 is X plus 7. You covered your ass there. What's the number? Anything you want it to be. I put an X there. Right? Here's the subtraction, difference, minus, so forth. Multiplication, product. Right? That's one of the words that we sometimes forget is what multiplication is. Times, of course, is an obvious one. Double, triple, those kind of things mean multiply. Division is quotient. That's the main one, right? Quotient's the freakiest one. We don't hear that word as much. How many times we go into something, per something? So those are all division ideas. So obviously, some of you guys realize where we're headed very soon. Translations from English into math and vice versa. And of course, that's difficult because it is a foreign language. Okay, so let's do this. I want to keep this kind of organized. It's going to be a quick little field trip. We're not going to be out there for like half an hour or something. I only have a few